language provides, and they are typically built into the language just because they are primitive data types. All the other data types are built upon these primitive data types, and we will actually build some more complex data types whenever we start talking about classes and things like that. So integer is a primitive data type, but we also have other types of numbers. An integer is a whole number. It can be negative, positive, or zero, but sometimes we need a little bit more precision than what an integer can give us, and that's where the decimal place comes into play, and we have multiple decimal placed types of numbers. The first one is a floating point number. I'm going to call that foo. And 3.14. Now, there's a problem here because we have so many different types of decimaled numbers. We have to specify what type of number it is. By default, everything actually goes as a double floating point number, which is a floating point number that has a greater breadth of precision. So if we change this to double, which is also a primitive data type, then the red squiggly goes away. But let's change this back to float. The red squiggly is here, so we have to say that this number is a floating point, so we put an F at the end, and then the red squiggly goes away. Now, the problem with floating point numbers is that they are not accurate, and it's not a problem necessarily with C#, it's just a problem with floating point numbers in general. Any programming language that has a floating point number data type has issues, and it's just because they all implemented the floating point data type based upon the floating type standard. So if you do some arithmetic with decimal places, you might not get the results that you are actually expecting. Like, for example, if you took 2.5 plus 2.5, you might not get 5. You might get 4.99 or 5.01 or something. I don't really know what you'll get, but there are some cases where you will not get the actual result that you were expecting. In cases like that, and by the way, that's for float, that's also for double, because double is just a larger floating point. For accuracy, for things that you need absolute accuracy with a decimal number, you can use the decimal data type. This too is a primitive data type. And you use the character M at the end of the number to specify that this is a decimal data type. And decimals are extremely accurate. You can use them for currency. You would not want to use a floating point number for currency because they aren't accurate, but decimals are accurate. And this is why many other languages have other types of decimaled numbers, like C# does. C# has a floating point, a double floating point, and a decimal. And it's because floating points aren't accurate. So C#, Java, I believe C++, most of these languages have a true decimaled data type that is 100% accurate so that you can work with currency and things like that. So those are the majority of the numbers. Let's look at characters. A character has a keyword of char. And a character is just a single character. It is not a string. If we try to assign a string to a character, we are going to get an error because a string is not a character and a character is not a string. So to specify a character, we use the single quote instead of the double quote, and the red squiggly goes away. And a character is only one character. We cannot put two characters inside of a character literal. We get an error and it says too many characters in a character literal. So a character is only one character. And a string is a string of characters, and we'll talk about strings later on. A string is not a primitive data type. Okay, so we've covered integers, floating points, decimals, characters. We need booleans because booleans are very important. It's actually spelled boolean like that, but the keyword is bool, foo, and this is a true or false value. So it can be true or it can be false. A Boolean is a lot like a bit. In the computer system, a bit has two states. It can be either on or off. So a Boolean, a true would be on, and a false would be off. So that is the Boolean value. And I think that is it. Well, there are actually other primitive data types, but for the sake of simplicity, I think I'm just going to leave it at that, because there are things like bytes. There's also different types of integers that we can look at. So just to keep things a little bit simple, we're just going to stick with those primitive data types. In tomorrow's lesson, we are going to focus more on the numbered data types, the integers, the floating points, and the decimals, and we are going to look at some of the arithmetic operators, because math is something that we have to do in our programs.